Okay, let's carry on. So far, your problem is you have not putting in the effort. That's the reason why you're not improving. And then you have phobia. Of course, you have phobia because more and more you forget. Then you don't know. You don't know how to do it. I'm the one that benefit. And I'm the one who teach you. Page 128. Right? Teach you some of the topics are new to me. Now, topics when I was your age, I couldn't do it because they're not asked the teacher. But now I have to work through it, check the answer. Now I can do it. Okay, we go to 22.2, refraction at spherical surfaces. Right, page 128. Hope you have your book. Make sure every time you come with your book, pencil, pen, paper, calculator, all must be ready. Right, syllabus. Basically, use the formula. They didn't say derive. Right, you want a derivation, can refer to your book. So know how to use it. Right, use only. Okay, let's just review what you have studied. Refraction at plane surface. Right? The white one is the medium one. Blue one is the medium 2. So the ray coming in from medium 1, that is called the angle of incidence. That's the normal line, perpendicular to the surface. And this is the angle made with the normal, the reflected ray. It's called the angle. Yeah.
So sorry, I didn't bring my semester 3 book because now I stay in my grandparents' house. They went away for 2 days. So now I'm staying in my mom's house. So I didn't bring the books. I forgot already.
Okay, then you just pay attention.
Okay, sure.
Right? Remember, if this is denser, right? That means the reflective index is larger in medium 2. So it's instead of it going straight through, it's reflected towards the normal. Right? So what is refraction? Bending of light when it moves from one medium to another medium of different density. Right? Different density means different reflective index. It's due to change in velocity of light as it travels from one medium to another. Right? It may not be tested directly, but I think you are expected to know what you have done in your STPM. Laws of refraction, right? The incident ray, the reflected ray, the normal, they are on the same plane, on the same surface. And then the ratio of sine I over sine R is a constant. And this is called Snell's law. And then the reflective index is sine I over sine R. Right? It's taken from, if this is air or vacuum, and then this is the medium. So the reflective index of the medium is just your sine I or sine R. So it's always greater than 1. For light traveling from medium 1, right? Medium 1 doesn't have to be air. It can be something else. It can be plastic, and then there can be glass. To medium 2, the reflective index is given by, right? This one show you from 1 to 2. So sine I over sine R. When medium 1 is vacuum, right? The medium 1 is vacuum. The reflective index is called absolute reflective index of medium 2. Okay, absolute reflective index of medium 2 is sine I over sine R. If this is vacuum. Okay, we call that line there boundary or interface, right? Boundary or interface. Refraction at boundary between two material, right? This medium 1, this medium 2. Or one with reflective index N1, one with reflective index N2. Refraction at boundary between two materials of reflective index N1, N2 is N1 sine theta Sin theta 1 and 2 sin theta 2. If you like, you can just take the refractive index and the sine of the angle in that medium. They are constant. Okay. Refraction as spherical surface, convex surface. Think of this as your convex lens, if you like. Same idea. Right? This is your object there. There's the ray coming from the object. And then it is refracted to the image there. This is the object distance, u. Right? That's the pole there. And that is your v. Image distance, n1, n2. That's where the direction of light comes through. So u is positive. In this case, your r and v in this place, this location is positive. Okay. Convex surface curve into less dense medium. Okay. This is less dense, is more dense. So this is a convex surface. N2 is greater than N1. So that's the formula. This one, you want it positive. Right? It can be N2 minus N1 or N1 minus N2, but you want a positive value. N1 is always divided by U, object distance. N2 is the second medium where you find the image. So if the image is here on this side, left-hand side, then it will be negative. Right? We use the idea the real is positive. I think your book make a mistake. Right? Instead of R, it put V. Sign convention. Right? If you use this surface, that's where your object is. Direction of ray coming from the left-hand side. U is positive. Right? And likely that if it's virtual image, then V is negative. And then since R is on the same side as the object, we can call it negative. V is positive, is on the right-hand side. Right? If U is a virtual object, then it's negative. This is a sign convention that we use. Concave, in this case, concave surface. Right? The surface curve into the denser medium. Right? The one look like a cave, if you like. Is the denser medium. Right? Same formula, not different. Right? We are still using real is positive. Right? Think of this example of this type of surfaces would be your concave lens. Right? Concave lens. Okay, so far? Any question?
Raj, go back from the first slide. I just want to understand it.
Which one?
No, from the earlier one you told me. I just want to go through in case I don't understand.
Which slide?
Okay. Yeah, 33. Just want to go through.
Okay, reflect towards the normal if this is denser, medium, that's all. And then you need to know that the light can come from here, right? Can come from here, and then it will go out that way. Reversibility of light, same direction. If it's coming from here, if it's coming from the denser medium to the less dense medium, it reflects away from the normal.
Okay. Next slide, sir.
Okay. Anything that is not clear?
Incident ray, reflected ray, same plane. Yes, this is all SPM work. Yeah, all okay. Next slide, sir. Wait, so the medium one is a vacuum. So vacuum means there's no air.
It can be air, it can be air or vacuum because the reflective index of vacuum and air is quite close to each other. But usually the actual definition is vacuum.
Okay, next slide, sir. Oh, it's the same thing lah. Yeah, okay.
Okay, anything else?
Where are you?
Yep, anything
Which
else?
is R and which?
Say again.
No, direction of light U, and then they put the R and V. Which one? Oh, U is the object, V is the image, the R is the radius of curvature. Is it?
Yep. Can use capital R, can use small r, up to you.
No, radius of curvature can also be up also, right?
What do you mean by up? This is
No,
the
I
radius.
mean,
This is your C.
no, yes.
That's your radius of curvature.
Focal length, right?
This is a part of a big circle, that's all. Big sphere, that's all.
No, focal length, right?
Focal length, don't worry about focal length lah. Focal length is just here. Halfway there, that's all. Don't worry about focal length.
Where? Oh, focal length is 1/2R, so it's 1/2 of the radius.
We will come to it later on, focal length. Now we are going to radial curvature, we are not using focal length. Tomorrow we'll go to focal length.
Okay.
Okay. If okay, we'll solve some problem.
Yeah, okay.
Okay. I hope your worksheet is with you. Our worksheet, I don't know how to teach you today. You're wasting your money.
Worksheet now you need.
Is your worksheet with you?
Not.
Then how are you going to study today?
Hmm.
How are you going to study today? I already told you last night already. Everything must be ready. You're very irresponsible. How to do? You tell me. Book is important and you leave it at your grandma's house.
Then just have half an hour today and then
I'm not going to do that. I'm not going to do that. I'm going to teach you. You don't understand, that's your problem. I'm not going to bargain with you. 1 hour means 1 hour. You are supposed to be disciplined. Okay, go and solve this question. The point S is 25 cm for, sorry. You always come with excuses. I already told you already. I give you already instruction. Expect you to obey instruction. Okay, go and do this question. The speck of dust is 3 cm from the center of a glass sphere with radius 5 cm. If the glass sphere is placed in a tank of glycerin with reflective index of 1.47, find the image distance as viewed from the diameter through the speck of dust from the far side. So draw a picture, what is happening. Right? There's your glass sphere, reflective index, N1, 1.5. And then you have the reflective index of glycerin. The blue one is the glycerin. N2 is 1.47. I call it N1 because that is where your object is. This is your object, your dust. And your dust is, this is your radius of curvature. Right? Radius is 5 cm. And this one is 3 cm. OC is 3 cm. That is where you are observing this dust. As the observer. So see whether you can get the answer. Just applying the formula, that's all. Okay, let's use the formula and solve it. Just where, if you want, you can draw. That's where your light ray coming from, object, going out. Right? And instead of it going straight through, right? You have different reflective index, denser. Then draw your normal line. There's your normal line, or there's your center of curvature. So that is your radius. This is your normal. So you bend instead of denser, less, sorry, it moved to a less than, so it moved away from the normal instead of going straight through it, bend downwards there, bend that way there, changes direction. That's what we have just reviewed just now. Instead of it going straight through, it bend away from the normal, and you produce backwards, you will get your object image. That's where your image is. That's your image. I, there's the image distance. That's the object. Right? Radius 5 cm. That's your radius of the sphere. U, that's your U. Right? It's a curvature that we are looking at. Right? Concave surface. So U is your, that is your 5 cm plus your 3 cm, 8 cm. And put in the formula. Right? N1 is 1.5. That's your N1. That's your U. Right? Remember, our N1 is larger than N2. So in this case, we consider if N1 is less than N2, then we consider that as negative. But since this is larger, it's denser medium, so we can consider that as positive. That's a kind convention. So N1 is 1.5 over U. And N2 is 1.41 over V. And N2 is 1.47. N1 is 1.5. So you want the positive, calculate out. Don't have, write on paper. You are too comfortable, I tell you. That's why you are not learning anything. You are too spoiled. So we got minus 8.1 cm. Minus tell you that it's not on this side, not on the right hand side. This is your curvature. This is a spherical surface. It's not on the right side, but on the left hand side. Right? That's the point that we reference. That's your V. Right? 8 cm on the same side as the object. Anything that is not clear?
No clear so far.
Okay, since you didn't have your
No,
book,
yeah, but the question can do, but the drawing can't visualize.
say again.
No, I mean when want to imagine how it comes out, right? So the drawing I can't visualize, but the calculation I can do lah. So.
Drawing is why is the problem? Drawing is
No, the one.
this is your sphere, the glass sphere.
Okay.
And then this is your glycerin outside there. I just change the color, that's all. And then you have a dust there. You just have to learn to know where the dust is. This is your object. That's your object. That's the center of curvature. You have to learn to understand the question itself. That's your job, to learn to understand the question. Right? If you don't know how to, you don't understand the question, that's where you will get it wrong. Right? First thing, you must, first important thing is to know, draw the diagram roughly. Then you can solve your problem. If not, how are you going to solve your problem? Okay. I don't know how you're going to survive tomorrow. Anyway, you are not, as I say, your heart is not with me. That's why if I've not taken up you, I won't teach you anymore. Because you are not serious with your study. You always give excuse, it's phobia. It's not phobia. You're lazy. Try this question. The figure shows a coin. This is your coin. Start on the surface of the glass sphere. Sorry, this is your coin. That's your coin. Sorry, that's your coin. Start on the surface of glass sphere. This is a glass sphere. Reflective index of the glass is there. Diameter 12 cm. Find the position of the image of the coin if it is seen from the other side of the sphere. From this side, at the other side of the sphere. Along with the diameter, neglecting the thickness of the coin. Think of the coin there as just a dot. Okay, calculate out and tell me the position of the image.
Okay.
Right? Should be able to draw the diagram.
This is convex or concave? This is convex. Just give me 1 minute, sir.
Yeah, what's your answer?
Okay,
Same as the first question.
1.5 over 12 plus 1 over V. So, what's the radius? Radius is 6. So,
Okay, you'll be able to draw. That's where the ray will come from the object. Then draw the normal. That's the radius. So that's your normal. Right? Less dense. Less dense, it will go away, not towards the normal. Away. Then it produce backwards. And where the image is. Right? Write down what is given. Radius is given. Right? This is object distance now. That's your curved surface. There's your concave surface. There's your object.
negative 24. Yeah, that's the formula I used.
So that's the formula.
The
N1,
answer get 24 one.
N1 is 1.5. And then 12, then 1.0. N2 is 1.0. That's what you want to find V. Then you want the positive answer from here. 1.5 minus 1 or 1 minus 1.5 doesn't matter. Calculate out. Okay, you're right. 24 minus 24. So you should be able to interpret minus 24 as means on this side. On this side. We're not worried about this surface. We're worried about only this surface.
Teacher, but here they never put convex or concave. So how do you identify?
You have to decide. You have to decide yourself. Right? That is your dust. So we're not worried about this side. The light is going to go that way. So this is going to be your concave. Right? Concave. But it is different from right? Previously where we use negative, we have to say that this is smaller than that one there, but this is not, this is larger. Okay, this is larger. So that's why we didn't put negative here. Right? If this is smaller than N2, then yes, we have to use negative here. That's a sign convention. Okay, that is your work for today. Leave it for you to do. Tomorrow we'll try that one out. Okay, we'll carry on with the lecture. You decide 1 hour, we have 1 hour. No more change of time already. Let's finish the lecture. Okay, just now was this is larger than that one there. Right? If you follow that, then you get negative. Okay, that's why we use positive for R because it's N1 is greater than N2. Right? For this one. Okay, so we have studied this part. We have covered all that formula and we need to know how to use it. Okay, thin lenses. Thin lenses supposed to be 3 teaching period. Use this formula to derive this formula. And then the lens maker's equation. Use the thin lens formula for lens maker's equation. Right? It means you need to know how to use this equation and this equation. Okay, you need to know right, how to derive this equation. Okay, that's your SPM work.
Sure.
Yeah.
Is there a 10-minute break or teacher is still going on?
The lecture will carry on unless there is
Okay.
they want to stop the Zoom. If not, we carry on.
Oh no. Usually teacher the one will say 10 minutes break. So I thought,
You want 10 minutes, you want 5 minutes break, can give you 5 minutes break, no problem with me. But you will cut
then continue then lah.
Your video because these are all continuous thing. If it's a different topic, then okay. Right? So you want 5 minutes break or you want to carry on?
5 minutes break, sir.
Okay. We start a new Zoom then. Okay, we have 5 minutes break, so I will stop the Zoom.